So far, suspected armyworm outbreaks have been reported in Zambia, Zimbabwe, Malawi and South Africa.
It's come from the Americas, possibly through imported food, and thrives in Africa's weather.
And it's unclear how it reached Africa.
One aspect of an armyworm outbreak is the potential poisoning of grazing livestock.
Texas, thanks to our recent rain, they have been destroying acres of hay and grass.
Food is everything people strive to secure for life survival. Maize is one of the most important food crops in southeastern Africa. Malawi, Mozambique and Zambia are among the countries that depend much on maize production. Nevertheless, maize has tested the unprecedented attacks from a new pest, the fall armyworm, scientifically known as the Spodoptera frigipeda, originated from Central and South America.
My name is Dr. Placid Mike Gabriel Mpeketula, lecturer at the University of Malawi. Yes, I have expertise in soil microbiology and I am very interested in research that is investigating on the roles of microbes in ecosystem processes, also the different interactions and relationships between microbial communities in the environment. So the fall armyworm, the Latin name or scientific name is Spodoptera frigipeda, and it is a species that belongs to the order Lepidoptera.
The invasive crop-eating pests are capable of spreading like wildfire in a blink of an eye. The insects can fly over long distances, 100 kilometers per night, and ravage crops all year round in given regions, preferably the tropical and subtropical climate. The fall armyworm can eat maize and some other crops, including rice, vegetables, groundnuts and cotton. Indeed, they are a legion of crop destroyers. They are not the only devastating creatures, posing high threat to food security and livelihoods of millions of small-scale farmers, but also the worst nightmare of economists. The fall armyworms were first reported in Malawi in December 2016. It is estimated that over 35,000 hectares of maize and 134,000 farming families have been affected by this pest to date. In Mozambique, the fall armyworm case was first reported officially in January 2017 from the Provincial Directorate of Agriculture and Food Security. In Zambia, the fall armyworm case was first noticed in December 2016 at the same time as was discovered in Malawi. The effect was far devastating, with over 279,000 farmers having their crops damaged over a land of 222,000 hectares in the central Copperbelt, eastern Luapula, Lusaka, Muchinga, and many provinces of the country. The fall armyworms are very hostile and highly prolific.
What is more bothering is really the larval stage of the moth, because it changes stages and becomes a moth. So when it is in the larval stage, this is particularly where it is problematic. The larva eats the foliage, and the foliage of all, literally, the crops that we have, maize particularly, and any other. What is even more disturbing is that this larva is able to devour these crops across literally all the seasons.
In efforts to control the pest, in all the three countries, farmers have used most synthetic pesticides, but the outcome has not been satisfactory despite the continued application. The Millennium Development Goals set a provision for nations to ensure environmental sustainability as the goal number 7 requires. However, the use of such synthetic pesticides or insecticides would even cause more danger on life and the environment, which may also contradict with the Millennium Goal number 1 as well as Sustainable Development Goals 2, 3, and 13 that seek to eradicate hunger and ensure healthier humanity and environmental sustainability through climate action. The agricultural research scientists in Malawi, under the collaboration of Department of Agriculture Research Services and the Chancellor College of Malawi, have undertaken a step to assess the short-term effects of application of pesticides. This serves as a means of control against the fall armyworm in maize, with emphasis on soil health, crop nutrient uptake, quality of maize grain for human consumption, and maize stover as fodder.
There is an influx, an unregulated influx of chemicals for the management of the fall armyworm. And so farmers are using these chemicals without knowing the effects of these chemicals on the environment or even on food quality. And so this is what is happening. People just using chemicals that are on the market anyhow without regard to whether these chemicals are harmful or not.
As an animal scientist, we identify gaps in the farming community, particularly with livestock farmers, and we try to address those challenges by doing research. So normally when we identify gaps, we have to design like research activities which are implemented like to answer the problems that farmers face.
The initiative is supported with the funding from Agriculture Sector-Wide Approach Support Project, ASWAP 2.
Smallholder farmers, they use crop residues as livestock feed. This fall armyworm, as is so devastating, I think there have been so many measures, particularly like spraying with pesticides. And we know these pesticides, these are chemicals. When we spray to the plant, we suspect there could be some residues in the crop residues. So we are trying to trace whether when we are feeding these crop residues to livestock, do we also like subject our livestock to these chemicals or to the traces that are found in the crop residues. So here at the Chancellor College, we are doing lab studies to see whether we can be able to trace the residues of these different pesticides so that we can advise the government or even the farming community on some of these chemicals. We're not saying currently that there's already a threat, but after this study, we'll be able to say maybe this kind of pesticide, we have traces and it's dangerous. Or we could have also some of these pesticides which may not have traces, which we can say, no, I think it's okay. Yeah, it's okay, we can continue to use these pesticides. So this will help to advise the government or the farming community what is supposed to do.
The impacts of such synthetic chemical compounds cannot be assumed and overrated, as life in the ecosystems is centralized on food chain, symbiosis, and other shared factors. It is very precarious for lives of various unfortunate species that become vulnerable of such synthetic chemical compounds.
In terms of significance, this research is going to actually bring to light the chemicals that are environmentally friendly, but also are safe to use for human health.
In this laboratory, I do conduct mostly the analysis, especially on animal feeds. Here in the laboratory, we have samples which were collected from different sites. So we would like to look into those samples where the pesticides contains in the residues which we are giving to our animals. Is there any chemicals contained in those residues? If they contain in those residues, can there be any effect to our animals, and at what levels are those chemicals in the residues? And also to find out the nutritive value of the residues which we are giving to our animals. When the dairy farmer feeds the animal, we also consume as human beings the milk. So we also want to know these elements will still also active or will be available in the milk. So this project we want to analyze those residues and if it is harmful to human consumption as we are taking our dairy milk.
The management of the fall armyworm has proven complex in the region as the pest is migratory in its nature. It is important that these countries coordinate and step up their research and management efforts against this pest. To better understand the interaction between the pesticides, the soils, people, and other organisms, samples are collected from the experimental sites. The samples are therefore taken to the major labs in the research institutions at Chancellor College Biological Research Unit and Vumwe Research Station for analysis using the required research procedures.
The samples we collect leaves, stems, and soil. We are looking at these pesticides we are applying. We are looking at maybe they can be harmful to human beings, to soil microorganisms, and also livestock. As you know, livestock, they feed on these leaves and stems for crops. And also in the soil there are some microorganisms which can also be affected by these pesticides we are applying. And another sample we are collecting is maize itself, grain, whereby we are looking at the human being part of it. How can it be? How can it affect the human being? Since some chemicals they have got this residue, they have got some residues. After you apply, there's some residual effects that can be there. That's what we are looking for. The samples we are digesting today, they are from the previous season. So this time around, we will go back to the field and collect some samples to be digested and evaluated, so that when we are sure that okay, this chemical is good, it doesn't have problems to human beings and our livestock, it can continue being on the market. But if there is some chemicals which we may feel like, no, this chemical is having some side effects, the analysis shows that it has got some side effects, then that chemical can be removed from the market.
In this process, the overall data is analyzed using the bioinformatics tools, the MASO, and the phylogenetic analysis by employing Kimura 2 parameter. It is such a complex scientific investigation which offers a high advantage in reducing errors in the scientific investigation.
On this project, we are looking on so many parameters that we want to analyze from using this instrument. There is so many parameters we are working on this project, and one of these parameters, the work which we are carrying on the atomic absorption spectrophotometer. This machine which you see here is what we call atomic absorption spectrophotometer, and it's an edge-length type. On this machine we can do a lot of, we can do analysis of metals like lead, mercury, magnesium, and so many metals which you may know. On this one, we have more than 180 samples which are going to be analyzed here. And the metals which we are going to analyze in this machine, right now we have 10 metals. We have cadmium, copper, iron, zinc, calcium, magnesium, arsenic, mercury, chromium, and potassium.
As the nations are fighting hard for sustainable development, it is very crucial to achieve such goals if green innovations and science lag behind. The planet is being treated with the continuous use of harmful compounds that are being added to our environment every second. Most damages that are caused are costly to be reversed. In the worst case scenarios, they are irreparable.